Okay, so welcome back, everybody, and thank you for joining us for the panel on leaderboardism and its role in natural language processing research at the moment. So we have a great panel for you, and we will start by letting the panelists introduce themselves. Why don't we go in the order in which I see you, which is completely random? And the first is Jesse.
Hi, so my name is Jesse Dodge. I am a postdoc at the Allen Institute for AI. My research has focused on efficiency and reproducibility, and I have been outspoken about ways that we can improve leaderboards and model comparisons in general across NLP and a bit in machine learning. Some work that I've done recently is on reproducibility. So I built the reproducibility checklist that was used for all submissions here at EMNLP, partly to help address, it's a very similar concept. I want to address the idea of just reporting a single number. I don't think that's great for science. So I'm happy to say that that checklist will also be used at NACL, which is upcoming. So it's I'm excited about the progress the field is making towards beating leaderboardism.
And the next up is Rachael.
Hi, I'm Rachael. I'm currently at Raza, which is an open source startup that has a conversational AI framework. And my PhD was at the University of Washington, and my focus was on computational sociolinguistics. So NLP focused on social differences in both perception and production of language, particularly speech. I don't do speech much anymore. And then after that, I was at Kaggle, where I worked quite a bit on also reproducibility and lots of leaderboards, as you might imagine. And now I'm at Raza. And my job role is developer advocate. So I'm mainly focused on developer education. And the folks that I work with need to have conversational AI that really works, for real, for real.
Excellent. And the last up is Kawin.
Hi, everyone. My name is Kawin. I'm a PhD student at Stanford working with Danny Jarafsky. Traditionally, I used to work more in like representation learning, understanding more like the theoretical properties of our word embeddings. And then sort of I was automated out of a job by BERT and all these contextualized representations. So now I'm working increasingly on higher level problems, like if we're measuring bias, are we doing that correctly, using confidence intervals and whatnot. And also I had a paper at EMNLP this year on leaderboards and why they don't do what we'd like them to do, or at least completely, and drawing from economics to kind of formalize this notion of what's being incentivized versus what do we really want.
All right. So with that in mind, let us jump right into the core question. And I guess the core question is, what is good and what is bad about leaderboards? Why? Well, obviously, they're a big thing in the field and big enough that for us to have this panel. And obviously, we have strong feelings about them, all of us. But do we think that it's just the bad things or just the good things? Yeah, what's the balance? And maybe let's go in the same order we did, so nobody's confused.
Yeah, okay. So I think leaderboards, I am of two minds about leaderboards, because on the one hand, they absolutely have driven progress in our field. It's been very helpful to have a place where you can measure progress. It creates opportunities for people to compete, which is very motivational. It provides, one of the easiest ways to get a paper published is to be at the top of some leaderboard with some new model that you introduce. So our field definitely is driven by a lot of progress on leaderboards. And also I would argue here, and this is maybe going to come up throughout the rest of this panel, that it's not just about leaderboards in particular, but also in every paper that we write, every time we include a table of results, for example, at the end of your paper where you're claiming that your newly introduced approach is better than the approaches that came before, that's better than your baselines, that is in effect a small leaderboard that is in your paper. And so really the same concepts we'll be talking about today about providing incentive for people to improve on some task, whatever, it applies at the leaderboard level, but it also applies at the level of when we write a paper or discuss our own work, even just within, one paper that we're writing or submitting. So I think leaderboards are great in that they have measured progress and then provided incentives for people to really build new approaches, et cetera. At the same time, just ranking a bunch of systems based on 1 point estimate of performance, you run 1,000 experiments, choose the best one of those, put that on a leaderboard, that really masks so much of what we do in machine learning and NLP. There's so much that went into that that just isn't incorporated into that leaderboard, that I think it can be problematic for people who are trying to do good science and build on the work that's presented on leaderboards. So yeah, there's, the good and the bad. Definitely, there's a lot of both. I'm excited about the future of our field. Like I'm optimistic. People seem to recognize there are issues, even though it really is the case that, the glue leaderboard or some super glue, the new benchmarks that are being introduced have a really large impact and have people actively try to, improve on them all the time. That's a major driver of research progress.
I would echo a lot of what Jesse said. I think leaderboards really drive excitement and focus, and can also make problems that would otherwise be inaccessible, particularly to newer researchers, a lot more available. So not having to collect your own data, not having to figure out what good metrics are for a problem, and really being able to focus on just, algorithm development and design, I think does make it faster for students to get started with something. Like you could assign, hey, hack away on this leaderboard as a pretty reasonable class project. And I also think that they have the benefit of getting interest in data sets. So if you have a data set paper with a leaderboard, people might actually use it inside your paper. And I know that in terms of like work by researchers to material career rewards, databases are particularly poorly matched, I would argue. And I think as for me, as somebody in industry who's working with people who want systems to work well, I think the biggest struggle is when a system that does really well on a leaderboard gets a lot of hype, people are really excited about it, and then they try to put it into production and it's too big, it's too slow. It works well in these very general use cases, it doesn't work on their specific thing that they need, or it can't handle like a very specific requirement they have for, let's say, dependencies. Like I need, just as a random example, I need all my code to run in COBOL, right? So it's a mixed bag. I don't think they're bad. I don't think we should not have them. I don't think the whole field should be leaderboard driven.
Yeah, so I think one way to look at like the benefits of leaderboards is to compare NLP to fields that in CS that don't use leaderboards. So I gave a talk at the HCI group at Stanford recently, and one thing a prof there pointed out was that in HCI, they don't really use leaderboards. And so the emphasis when it comes to research is really on novelty over everything. Because if you innovate on someone else's work and say, hey, I did what you did, but I did it better, then it's really hard to prove that, just because because due to like the inherent nature of the field, there's no way to like systematically reproduce prior results and say that your work is without a doubt the better way of doing things. And so the emphasis is constantly on novelty, and it's hard to measure progress. So leaderboards in that way are really a kind of blessing, because we can quantifiably say, I mean, it's not perfect by any means. Again, like you pick the random seed that does the best and whatnot, but it is at least better than nothing. It tells us we're making some sort of rough stochastic progress, which is good to have. And I think it helps. And I think a really great thing about leaderboards is that they clearly define the problem to work on. It says, okay, like you should do better than this model on this data set. So if you're a student and you want to work on something, wow, this is a great problem. It's fully defined. But you can grow like far too parochial. It's basically like if you're a company and you're only optimizing for revenue, but not costs, like you can run your company into the ground. And I think that's what happens when we put all of our faith in leaderboards. But I think slowly, like people are realizing those limitations and wondering how can we reshape leaderboards to better align with our values, or maybe adopt a different paradigm altogether.
Okay, thank you guys for for all these great points, and to build directly on all of that. Which of these pros and cons do you think played most into the fact that leaderboards are just so popular in the field right now? What is the key factor that makes most of NLP about leaderboards at the moment?
I think that a main reason that we've seen such wide adoption of leaderboards is because they're simple. It's a very simple idea. I think this builds on what Rachel was saying about how even as a class project, a professor can say, like, just go make some submission to this leaderboard, do something. You know how we're going to evaluate the thing. And so you can use that evaluation process to drive how you will build your model or train on your data, what have you. And so really, I think the reason that they're so popular is because they're simple. And so part of my work has been trying to get the community to not just acknowledge, but also adopt ideas that are just a little more complicated. Like leaderboards are simple and it's great. It would be wonderful if it was enough for us to put a table of results in our paper and call it good. But it's not, right? Like that's one table in 8 pages of describing what you've done. And I think one theme that's come up also, it's an interesting time in NLP. I think I've now been in the field long enough to see at the beginning of my PhD, quite a while ago now, neural models were not popular at all. People just didn't really use them. Our models were simple then too. And so leaderboards at the time, I think they were smaller, less popular, but also perhaps more appropriate, because training logistic regression is almost a deterministic process, right? There isn't a lot of, there certainly aren't as many hyperparameters with those old systems. And I think that's when we sort of grounded our field in leaderboards. Whereas today, training these really large, complicated neural models, there's a lot of sort of quote unquote black magic that goes into that. And all of that is obfuscated by the simplicity of the leaderboards that we see. So I think the main reason is simplicity. I wish that it was easy to convince a large group of individual researchers to individually all provide a more complicated and thorough analysis of how their models compare to previous work. Obviously, we can't. That's perhaps a positive and a negative of research, is that everyone can sort of do their own thing. But I do think, why is NLP so driven by leaderboards? It's also tied in with, it's not just about that historical aspect I mentioned, but it's also tied in with fame and sort of media, and also how we get promotions. Because if I top some leaderboard, it's more likely I'll put that on my CV. There might be some news article written about it, this new model that just came out, and that really does perpetuate the idea that leaderboards count for something, and we should be putting effort into improving on them.
Yeah, I think similarly there, it reduces the language complexities to a pretty straightforward, easy to grasp way. And because the field has been growing so fast, I would wager a guess that most people working in NLP right now have little to no linguistics background. Like I've probably not taken like a formal semantics course or a morphology course or a linguistic typology course. So not needing to have that background and that understanding, or even to like know the language that you're working on and be able to speak it, again, just makes it easier. And if I were being particularly cynical, I might say that leaderboard papers are just easier to review because you can like flip through, look at the tables, bad numbers, skim, problem, give it a 1. Just don't do that. That's very rude. And I don't think a lot of people do that. But just the growth of the field, the fact that there's way more papers and people wanting to publish papers than there are qualified reviewers right now, that sort of like crushing workload. If I had to have, you know, a bunch of 90 style system papers that I needed to review in depth, and I had the same quantity as you would for like EACL now, that would be several full-time jobs. So I do think that the review crush is a part of it. And I hope that like the tackle style changes that are coming up will help with that disciplinary stuff.
Yeah, so I think a lot of great points have already been brought up. If I had to boil it down to like 3 key reasons, I would say 1, it's well defined. So because leaderboards abstract away a lot of the complexity of the underlying problem, they give you a very simple problem to work on. And I think that clarity is really helpful. The second part, I think, is like the gamification aspect of it. Like it's kind of fun to like see all these high scores and then your name at the top. And you have the high score. So for the same reason that like an arcade game might be popular, I think leaderboards have that sort of psychological aspect to them as well. And lastly, so I think this has been brought up a little, is precedence. So once a lot of people start justifying their contribution by saying we topped the leaderboard, that becomes kind of normalized in the community. And then you have reviewers saying, oh, well, why haven't you topped the leaderboard? I mean, this person was able to top the leaderboard. And then the sort of culture just starts reinforcing it in a positive feedback loop. And yeah, because of this well-definedness, this gamification, and the precedence aspect of it, I think leaderboards have come to dominate.
Okay, thank you for all these great points. So my next question is something that we have partly touched on already, but I'd like to just spell it out in more detail for folks. So what is the relation that leaderboards, well, leaderboards as the exercise that we are engaged in publishing NLP papers, what is that exercise, what is the relation between that exercise and A, science, and B, real world applications in industry? And you're free to comment on either or both of them to the extent of your expertise. Thank you.
So first, I'll just say, like, I'm starting to answer this question because I've been answering first for all of these. I would also be happy if we switched the order up for maybe the next one. But for this one, I have a lot of opinions, so I'll take it for now. And also, like, we've, generally the 3 of us seem to be in agreement on a lot of things. So maybe I'll make my opinions more strong and see if I can get them to disagree with me. So here, I think I would say that it's, in my opinion, leaderboards are actually, at this point, somewhat problematic for the future of science. And what I mean by that is we often see people publishing papers trying to get to the top of leaderboards, but then seeing that work not being reproducible. And again, this gets back to the idea that I said of people, when they write up a paper, focusing on just getting that paper through peer review. So they just focus on convincing the reviewer that their approach is better than previous work. But that's not actually why we read papers, right? We often, as practitioners of NLP, we will pick up a paper and skim it, maybe get some ideas. But if we want to do anything with that work, build on it, compare against it, we need to know a lot of additional information that's sometimes forgotten. It's not the necessary information that goes into, that's like often considered in the review process. So that's things like the actual experimental design, the hyperparameters that went into the experiments, a history of all of the different types of experiments, maybe architecture tweaking or pre-processing your data methods. And all of that is really what makes up the body of science. So to make progress, they say we stand on the shoulders of giants, and we really can't do that unless we have all of the experimental information that went into the previous work. So I think going forward, what I would like to see is not just, I agree, I think maybe one of the other 2 panelists said this earlier, that I think leaderboards are going to be around forever. It's such a simple idea. We're always going to be comparing against each other. That's going to be there. But what I want to see is a leaderboard that's augmented with so much additional information about all of the experiments that were run, the failed experiments. I think that's why I love this workshop, is because so often we do a hyperparameter search and then choose the best performing model of that search, or we just try different architectures, or we just try different ways of processing our data. And we don't use any of those experiments except the best one. And we then present that as like our new approach. But really, that is part of the process everyone goes through. And so when we don't present that information, like on a leaderboard, that makes it really hard, especially for the more junior students who don't have the expertise. They don't have that sort of, they don't know the black magic that goes into training our models. So what I want to see is much more focus on different metrics, not just performance, but efficiency, and then some summary. Like really what I would compare against would be something akin to a lab notebook, like we see in other fields, right? Like in biology or in chemistry, people record all of the experiments that they run with details about how they do that. In computer science, we can record all of that information. We end up with a lot of it often, but then so much of that is not reported on a leaderboard or in a paper. So really what I think should happen going forward, to the benefit of science, will be less focus on the single number and much more focus on our sort of collection of experiments, some of which quote unquote failed, but that is a necessary part of the NLP or machine learning process.
I'm going to go one spice here than Jesse and say that NLP, as it's currently practiced, is just straight up not a science. And I would also say that about computer science. Like very few NLP papers, like the cognitive modeling workshop for sure, are telling us about like advancing our understanding of the world and how it works. Like what does like the current roster of EMNLP papers tell us about capital L language and how it works and the human capacity for it? It tells us a lot about like different ways that we can, build lossy approximations of it computationally, but that's not the same thing. In terms of industry, I think the single biggest thing that leaderboards omit is cost. So just straight up, how much compute did it take? How much time did it take to train? How many people worked on it? And if like that's just going to be included in everybody's calculation when they're deciding whether or not to put a system into production or not. And we don't include it in leaderboards.
Yeah, so I think my take will probably not be as hot as the other two, but yeah, agree with both. I think like we've overfitted to leaderboards like as a community, and that has helped them, rendered them less useful, because again, like ideally we would be a science, but in practice, I think we're sort of an engineering field, but then even then we don't offer everything we should to make sure things are reproducible. Like I wouldn't want a civil engineer claiming that their bridge met some arbitrary metric and therefore we should all build that bridge. That would be a little scary. With respect to industry, I think some great feedback that I've gotten like as a result of writing the EMNLP paper on leaderboards is how much industry practice really differs from the research we do. So I was at GatherTown yesterday. Jade Abbott, who's at EMNLP, mentioned that the most popular model in industry is Distal Roberta, at least from what she had heard, which was pretty surprising to me because I don't really work with Distal Roberta, and most people around me don't really work with Distal Roberta. And yeah, so as Rachel mentioned, I think a major problem is that costs aren't factored into leaderboards. They're not cost sensitive at all. I mean, if you think of it as like a profit problem, then leaderboards only really tell you revenue, they don't give you costs. So your best performing model might actually drive you into the ground. And I think here's where like thinking of a leaderboard as like a consumer of models, as I do in the EMNLP paper, really helps, because then you can think of the divergence between, or you can frame the divergence between what leaderboards incentivize and what people want as a difference in utility functions. So for most business people in industry, the utility of like your accuracy probably plateaus after a certain point. Like you want it to be decently accurate, but like spending tons and tons of resources to get a 0.1% improvement in accuracy is just not worth it. Whereas the utility of leaderboards is very much like, a step function that's like flat for the most part, and then boom, number 2, and then state of the art is all the way up here, which is just not how people think of models. Yeah.
So Anna, do you mind if I ask a question also?
Oh, yeah, sure.
So so this is interesting. Thank you very much for all these comments. So it's interesting that the good aspects of leaderboardism that everybody mentioned are also the bad ones, right? So, you know, the leaderboards define the task really well, but then they define the task so well that you're just overfit to the task. And the leaderboards encourage competition, but then they encourage competition so much that then that's the only thing that people care about. So so it's interesting, but going back to the question of where is the science here, right? If we're after the science, where's the science? And I mean, you know, one can argue whether computer science in general is a science because we study human-made objects, but that's a separate issue. But really, if we're, you know, clearly leaderboards are useful, and knowing where we are in terms of SOTA is useful. But what makes a worthy contribution? At which point, and I think someone mentioned that, you know, maybe they used to make more sense when there was more determinism, and maybe now leaderboards end up being, you know, this lottery game where you report the best result, and, you know, and also encourage people to increase the size of their models and hope that that produces better results. And is there science in it? Okay, there isn't. So if that's the case, then what makes a worthy contribution, given all that we know, right? Given that we do want to make progress, that we can, you know, show, okay, this is progress. How do we define a worthy contribution?
I think that's a great question. I think also that ties into a lot of sort of reviewing practice in our field. I would argue, I would disagree here with Rachel that I do think NLP is a science, kind of. I'm trying to disagree on something. So I think it is a worthy field to study as a science. I think you're right that a lot of it is, you know, not driving forward our understanding of language. I do think also, you know, there are ways to do good science in our field. There are ways to have valuable contributions which either do or don't top leaderboards. And I think one interesting case study here is the Roberta paper, which you know, I'll bring up again. So that paper actually was rejected from, I think it was submitted to iClear, I'm not sure, but it was never published anywhere after that. It's just on arXiv. And it's clearly one of the most influential papers over the last year. I think it has more than 1,000 citations. I think that that is a valuable contribution, but in terms of sort of novelty, you know, the reviewers didn't agree, and then the field has moved so quickly that the paper just never ended up being published. So what is a valuable contribution? I think something that extends our understanding of the way that we do things. Like that seems to be the core concept for me of what would make a good scientific contribution. I think that for our field, there is certainly an aspect to it of engineering. So we definitely undervalue a lot of papers like Roberta, where they have a similar approach, perhaps get improved performance somehow. That paper happened to be the top of a leaderboard for a very brief period of time. But really, as long as we can learn from it, and I would argue that the way that we can learn from that is through a more extensive analysis or comprehensive review of the experiments that were run, I think that that can be something that currently isn't valued, but should be valued more by our community.
Yeah, this is hard not to turn into a wish list of papers that I want to see. I think what makes a good contribution, setting aside, let's say, how it does on a leaderboard, I am always really excited to see a paper that tries something new or something old that's just quirky, right? That just tries something off the beaten path. Maybe some sort of ensemble model that just like I haven't seen before or hasn't, you know, done well previously. And then regardless of how the model does, has a really detailed error analysis and says, okay, here's the types of places where this model and this approach works well. Here's what it does, you know, pretty well. Here's what it does badly. Here's the benefits and drawbacks, and then suggestions for how you could use that, right? I mean, I'm very I don't know, I'm very pragmatic, I care about whether I can use this in my job, basically. But I think it's also true of a lot of people in NLP, right? We're a very industry heavy field. There's nothing wrong with that. It's great that people use the stuff that researchers do in the field. So I think setting aside the questions of leaderboard, that's what's interesting to me. And the novelty is in trying and concatenating new things. Like, I think no one would say that like the Vaswani paper was a bad contribution, right? It's something completely new. And even if it hadn't, like transformers hadn't worked out well for a lot of problems, if they'd worked out well for like a small set of problems, it would still be really interesting, right? So that's my stance.
So I have a pretty lax definition of contribution. I think I would define a contribution as anything that provides non-negligible utility to like in the aggregate, right? So if you take a really common architecture and then you apply it to a really common problem, but nobody had done that before, then it might not be a terribly novel method or a terribly novel paper, but you might like bring a lot of utility to people who work on that problem. And in a broader sense, I think that a lot of papers that make good contributions are not, accepted to EMNLP conference or NLP conferences like the Roberta paper. They might not even, like they might just be the subject of a blog post, right? So I think contributions as like we define it in like the NLP academic world is much narrower. We require the contribution, we define the contribution implicitly as like an increase in utility in the aggregate that meets some arbitrary threshold. And part of the problem is everybody has their own idea of what this increase in utility is and what this threshold is. What one person thinks will be really useful because they recognize a problem that not a lot of people work on, another person who doesn't work in that area might think is totally useless. So, and as a result, reviewing has all sorts of problems. But yeah, like I think contribution is a big umbrella, and I'm happy to include a lot of projects under, I'm happy to say that a lot of work does make contributions, even if it doesn't receive a lot of public acclaim or get into an NLP conference.
And just as a footnote, I was specifically talking about systems papers, also like any data set paper. I'm always delighted to see.
Yeah, for sure.
So, I mean, maybe the way to go about it is, define, it's fine to be a leaderboard beater as long as you beat by some reasonable margin and it's replicable, right? So I think nobody would argue that, let's say introduction of attention to MT was a contribution, right? And because it improved results amongst other things, and it was substantial improvement, not accidental improvement, and it was replicable improvement. So I think if we define it this way, we might have an easier time kind of counteracting the bad aspects of leaderboardism.
Yeah, but you don't know if it's replicable improvement from one paper.
Well, that's the problem, right? So that's where we have to figure out how to do it better.
Right. So to kind of circle back to the topic of this whole workshop, and also to the last question of what makes a worthy contribution, I think it's a question that came up quite a few times today. Like, now that we have all these failures, how do we know that this actually will be interesting or needed by anybody? And yeah. But to me, it seems like if you're working on something and you have a paper that says what worked, to me, the value of that information is just as big as the value of a paper that says that something doesn't work for that problem. And yet we have such a huge discrepancy and publication bias against the latter. What do you guys think?
I agree. I think also now is an interesting time to be in this field in general, because there seems to be, now that the field has grown enough, we see enough examples of ways that our reviewing process isn't meeting the goals of the community. And so I think this workshop that you're organizing, I've said it before, I'll say it again, I love it. It's a great drive to promote reporting negative results. to pitch my own work a little bit as well, I've been involved with the machine learning retrospectives workshop, which is happening at NeurIPS. That happened at ICML as well. And in that workshop, we're trying to encourage people to look back on their own work and write a retrospective saying more about their process, what that was like and the impact that paper had, than just what went into those 8 pages in which the authors are trying to convince reviewers to pass some somewhat unknown, somewhat arbitrary bar. It's an interesting time to be in the field because I see all of these changes happening. I think it comes with growth. And I'm excited about maybe having more permanent venues for these kinds of, maybe less standard papers or papers that don't fit that sort of strict formula, that criteria of like trying to advance science on a particular topic by beating previous, like the best performance. We also see it a little bit in some of the tracks that are available for people to submit papers to. So Kawin's paper is a great example of that. There have been a number of other really interesting papers published that aren't trying to tackle leaderboard as like a leaderboard and instead trying to provide some additional information. I'm pretty convinced, it sounded like, maybe I would pitch this back to the other panelists as well. It did sound to me like we seem to agree that the Roberta paper as a paper that beat some, baselines should be something that's published. But I guess I wonder if there should be some separate track for that kind of thing, or if there should be some, just whatever you can do to beat some baselines or get to the top of some leaderboard without really trying to advance a lot of the scientific discourse around new models, new modeling ideas for language, et cetera. Or if that should be like sort of a standard part of just the general conference system.
Yeah, it's interesting and hard, right? And this isn't just an NLP problem, right? The file drawer problem, every science discipline, every discipline that has publishing basically in some sort of empirical results has it. And I don't know that there are to date any great solutions that I have seen. Like the fact of the matter is, doing research is extremely competitive. But I ain't a professor. That is what I went into grad school wanting to do. I don't think it's because I'm not like good at NLP. There's just not enough positions for everybody, and that's true. Across academia, across industry, maybe not industry, but across academia, across research in all fields, and the career incentives for publishing negative results just kind of aren't there. And I get it. Like, why would you spend time writing up and trying to like fight through the review process for this paper that you believe in, that says, hey, we try something and it stinks? Definitely don't do that, even though it's going to save people time, even though it's going to be a good contribution that will genuinely help somebody down the road. And I don't necessarily know that, hey, the system has been implemented and it does pretty well, and people in industry are using it, necessarily makes it an interesting research contribution. I think it makes it useful. I think it would make sense in an NLP setting particular, but I don't know that people are using this is necessarily good evidence that it, if we are treating NLP as a science, advances our understanding of the models we're using for language, I guess. Yeah, I don't know. It's hard, right? It stinks.
Yeah, I think like the key reason why there's a bias against negative results is that the space of negative results is simply a lot larger than the space of positive results. And so people think, so people sort of associate positive results with like difficulty, and then negative results with like, oh, like this is an easy outcome, which I don't think is necessarily the case. I think like there should be a more nuanced delineation within negative results. Like if you try something out that like in theory should work, like it's intuitive that it should work, but it ends up not working, then that's a really interesting negative result. Or if you apply sort of a new class of methods from like a different, like some theoretical branch of math, for example, and you get like sort of okay results, but not great, just the novelty of that alone should have some merit. And so the Roberta paper is, I think, again, going back to that, a really good case study. And to me, like the Roberta paper is almost like the canonical findings of EMNLP paper. Like it contributes something solid. Everybody recognizes that it's useful and that it deserves to be published and that people are getting a lot of benefit out of it. But maybe it's not like the subject, it's not a paper that you would typically maybe present at a conference. So I think findings of EMNLP and the sort of work that would go there would comprise some of these negative results. And I don't think it should be thought of as like any lesser than the typical NLP conferences. It's like a parallel branch for encompassing things that aren't just a good culture fit for NLP conferences as we know them.
I think, so I'll just be clear that part of my motivation for tossing that question back to you guys was from the Rocket Chat. Sam Bowman had asked this question about if it's worth trying to separate the goals of publishing papers that are aiming to move forward the science of NLP and those that are aiming to improve on some particular application. So a more sort of practical, maybe like the Roberta paper, you just improve some number, but maybe don't provide that many opportunities for sort of science and that kind of thing. So yeah, just to be clear, that's I think that's a really interesting question. I'm excited about the future of our field. I think there's some other questions here too in the Rocket Chat.
Yes, so I was about to just open the floor to all the audience. Please post your questions in the Rocket Chat, or yeah, I guess I don't see everybody, so I can't see raised hands. And unfortunately, Rachel can't see the Rocket Chat.
I trust y'all.
Jesse, Kevin, do you want to pick any of the people who asked questions? And
yeah, sure. So I think Sam asked a question directly of me or close to. So he asked, is it possible, as Kawin might be suggesting, to build a leaderboard that is adequate for both audiences, that is both industry and academia? So I think it is possible, but we would have to rethink what a leaderboard is exactly. So I don't, again, like, my problem isn't inherently with leaderboards, but more so with like leaderboard design and our expectations as a community of what leaderboards can do. So one thing that would be really helpful is, instead of having just like a single metric, which is typically like accuracy or F1 score, have or require the reporting of multiple different metrics. So like model size, what is the training time in flops, what is the inference latency, which is something people in industry really care about, and it require the reporting of these metrics, and then provide some sort of interface where users can specify different weights over these different metrics. So my utility function, if I were working in industry, might place a lot more weight on something like inference latency compared to someone in academia. So if I can specify my utility function in the leaderboard itself, and then effectively change the leaderboard's utility to match my own, then we now have a leaderboard that supports my preferences as a practitioner in industry, but can also be modified on the fly to conform to an academic's preferences. So it is possible, to some extent at least, I think, for a leaderboard to be able to accommodate these diverse preferences and work for both industry and academia, but it requires a redesign of our conception of leaderboards.
I like that idea a lot. And I also, so in my Green AI paper, we've been arguing that really what we should be comparing is performance efficiency trade-offs. So instead of just a single number, reporting training curves, or as you vary your model size or inference speed, really reporting those curves, and then comparing perhaps in a plot where we've seen some of this over the last few years, where papers are now starting to compare, for example, efficient net is not a model, it's a description of how to generate models of different sizes. With that, you can draw a curve that shows performance efficiency trade-offs, and you can't really put that on a leaderboard, right? A curve, like comparing two curves, isn't something that fits nicely in a ranked list. So what I expect to see more of going forward, especially in high quality research that's sort of the higher budget research evaluating multiple models of different sizes or different, if you train on, pre-train on all of Common Crawl, then providing performance efficiency trade-offs along your training data, your model size, the number of experiments you run. I think that kind of thing is maybe an improvement over what we'll see on leaderboards, and gets at this idea of being able to decide what point on that curve fits you best. And so I think that sort of builds on the personal preferences that Kawin is talking about.
Yeah, in my experience, the thing that matters during model selection for people with industrial applications is not how well does this model work in the abstract given some set of criteria, but how well does it work on my data? So honestly, this is the pipe dream, but like a bring your own data leaderboard, right? Where you have, the thing that you care about and you're like, which model does best, like on my thing and the one that I want. And then considering other things like, if I wanted to trade my own, how much would it cost and things like that. Yeah. I don't think that would be great for like evaluating. I think that that's a very end user specific evaluation method though.
I think that's actually a great, sorry to interrupt you, Anna. I think that's a great point though. So in reproducibility, we often talk about replicability, which is the ability to just reproduce the exact same number, while reproducibility is often defined as the ability to come to the same conclusion about which model performs best. And that's the kind of reproducibility I've been interested in. And really that does tie in with the ability of a model to generalize if you slightly perturb the data set or train on a similar, but again, slightly different domain. Perhaps your model, your conclusion about which of two high quality models performs best would change. And so really here, I think that it's, that's a general interest idea, not just specific to industry, but also for science. And the advantage of the GLUE leaderboard was it was trying to argue, one advantage of this was that it was trying to argue, this is a general language understanding task, which hopefully, I see Rachel kind of shaking her head. It was meant to show, if a model can perform consistently well across all of these tasks, maybe it will generalize to other language tasks as well. And that really gets at the heart of reproducibility and being able to draw reproducible conclusions and not just replicating the exact result, but having it be really fragile, where if you change anything in the setup, it will no longer hold. Yeah.
Yeah, I just added my comment on this performance efficiency trade-off, and that's for Rachel. So given that there is such a curve, would it be possible to select some or several points on this curve which the practitioners would be able to use to select the models on which to test with their own data? Because it wouldn't be perfect. You would still have to do that off the leaderboard, but it's better than trying them all, right?
Yeah, no, I definitely think it could be helpful.
So any other questions take your fancy?
There's a bunch of great questions in here. I have talked a little bit. So maybe I'll ask the other two panelists. So Dallas Card in the Rocket Chat asked about sites like Papers with Code, which effectively turn, this is what he wrote, which effectively turn published experiments on benchmark data sets into an implicit leaderboard. Is this exacerbating gamification or encouraging good reporting? I've actually worked with the Papers with Code people a little bit, so I will maybe see what your opinion is on this.
I think it's like a step in the right direction. So obviously reproducibility, having some reproducibility is better than nothing. I still don't think it's at the level where like ideally we want to make it trivial for anybody to reproduce these experiments, right? So something like you have a Python notebook or some other kind of notebook where you just sort of press enter and the experiments will be reproduced. If that's the gold standard, then we're still quite a distance from that. That being said, I think it's a step in the right direction. And with respect to like exacerbating the problems, I don't think it's like, it's so central to NLP that like a reviewer is going to criticize you for like something they saw in papers with code, right? So if anything, I think like the main subjects of discussion or the main offenders, if you want to use that word, is like glue or super glue, which is the canonical or the canonical leaderboards people point to. So I think papers with code is like a net benefit, if anything.
Yeah, I'd agree. I don't think it's driving or worsening the problem. And I don't know, being able to see if people are fishing for random seeds, for example, I think adds a little bit of a layer of accountability on top of stuff.
So yeah, I have been meeting with Robert from Papers with Code a bit to talk about how we could augment the leaderboards that are on there to include more information specifically around cost or the other experimental designs that went into getting those results. So I think that they are meeting a need of the community, providing those leaderboards, but also trying to improve upon it, which is great.
And I will say, replicating experiments, even if you have the code, is often not trivial for cost reasons.
So I think you're answering the question that Kyle Law answered implicitly. So he asked, to what extent do we think peer reviewers are able to assess reproducibility of a paper's finding given just the paper? Also, as a practitioner, if you read the paper and decide whether it's worth replicating or trying to use, like what is your success rate?
I'll say my success rate. So I think part of the reason I started working on reproducibility was because I had an abysmal success rate. It was a challenging way for me to start to work in the field where I think there were a couple papers in a row that I tried to reproduce and I just couldn't reproduce the results. And I was frustrated. And so I thought deeply about this and I have since sort of advocated for this as a way, I have a special place in my heart for junior grad students that are just figuring out how to do machine learning and NLP who are unable to, start a project because they can't get the baseline to work, because that was me. And so hopefully there's a lot that we're doing which can improve that over time. I do wonder how much it is the job of the reviewer to make that assessment. The reproducibility checklist is motivated by just reminding people of what they should include, but it doesn't require anything because all papers are different. And what should be included to make work reproducible is different between different applications, different types of models, et cetera. So going forward, I don't know if those should be two sort of separate jobs of assessing reproducibility and assessing the sort of scientific merit and whether or not something should be published or not. We will see. One thing that I've been working on with Papers with Code is I'm also involved in the reproducibility challenge, which is happening right now. EMNLP has joined. People can, especially it's aimed towards students, they can reproduce the results of a previously published paper at one of 7 conferences this year, and then submit their reproduction report. And what we plan to do is link the reproduction with the original work on Papers with Code. So hopefully that will provide additional information about what it took for other people to recreate those results.
I think it is buck wild to ask people to fully reproduce projects as part of their review process. It's just deeply impractical. I think it would be great. I think the field's going to have to change substantially. And they're also going to have to be like massive compute grants. And also just from an ecological standpoint, do we want to do that, you know?
Yeah, I think he's asking whether they even can guess how reproducible something is based on the paper. Of course, they won't even try likely, but I guess it does factor in their decisions whether they think this can possibly work.
But I mean, we're not the only ones who are dealing with this problem, right? There's issues with reproducibility in medical research, big issues, right? And there's various methods that people have tried to propose which haven't really been implemented. Like, let's say have two labs working on the same idea, right? And have them try to prove opposite hypotheses. So things like that. So unless we have some sort of system set up that changes the way the research is done, I don't think adding some, bells and whistles here and there will fix it, right?
Yeah, no, I definitely agree. I think reviewers should at least think about reproducibility, but I don't think it should be the core of the review process, just because there's so much mental work involved already. My own reproducibility success has been pretty good, actually, but the efficiency of that process has been abysmal, particularly in terms of taking, a single flat Python file with probably not 3 years, but a good couple months of work in it, and parsing things out and trying to, figure out what uncommented code is doing, and what connects to what model, and which of these experiments is which chunk of code, which I've written crappy experimental code myself. I'm not without guilt here, but at least for me, it's been more just sort of a code quality issue, which honestly I think something like papers with code can help with, because people can look at it.
Yeah, I don't think the responsibility of assessing the potential for reproducibility should fall on the reviewer. I think that's something that's really hard to ascertain just by reading the paper. And also reproducibility is you sort of have to condition it on the person doing the reproduction, right? So someone at Google or some large company will have access to far more resources. So for them, an idea may be much more reproducible than someone like me who doesn't have those resources. With respect to my success at reproducibility, I mean it's been pretty grim. I'd say I have a lot of suppressed trauma from my master's program when I tried to reproduce a lot of work. And I think in part it's actually informed the kind of problems I work on, where it's either a lot of meta level stuff and also a lot of the theoretical aspects of representation learning, just because of how much struggle it was to reproduce a lot of papers. But yeah, but I think the good thing though is that even if something ends up not being reproducible, that's kind of found out in the marketplace of ideas, right? So a paper might be accepted to a conference, but then it might not really gain any traction after the conference because it's not reproducible or it's way too hard to reproduce. And in fact, at least in my experience, at least in my experience with sentence embeddings, I found that a lot of the work that initially got traction was the really simple stuff that even when it didn't get SOTA, got a lot of traction. So this paper by Sanjeev Arora and Tengyu Ma on a clever weighted average sentence embedding that was very popular for a while. So to some level, I think the problem with reproducibility is sort of handled in the marketplace of ideas, but it's not perfect. And ideally, we want to catch that earlier on instead of subjecting people to the trauma of having to reproduce all of this themselves.
Yeah, I think also here, there's a couple things I'll say. So first, two ideas that you brought up here, I think are worth teasing apart. One is reproducibility, and the other is the availability of compute. And I would argue that we should, in fact, be holding all papers to a similar standard of reproducibility, not based on whether or not someone can run a bunch of additional experiments to reproduce those same ideas that were presented in the paper. Here, I think that gets at, those are two separate ideas. One is, can I reproduce the results based on the GPUs hours that they claim they used? And another is how much additional experimentation do I need to run to get at the same conclusion. Those are worth sort of keeping apart. And then what I usually say about reproducibility is, yes, it's true that as a field in general, we move in the right direction over the long term, but it's more about fixing those sort of small deviations where someone publishes a paper and it's not reproducible. It then takes, 6 months or a year for us to realize that. And that is holding our field back. We can instead make faster progress if we just do a better job of reporting our information and producing more reproducible research. So it's sort of a stochastic process, and we can reduce that stochasticity by having more reproducible results.
Thank you all so much. And this is such a great conversation that I kind of don't want us to stop it, even though we're running out of time. Do you guys want to take like one more question? Okay, is there something in the Rocket chat that you like? Rachel doesn't see it, but Jesse and Kevin do. Anything you like?
I think there's a lot of great questions in here. I'm trying to find one that's relatively simple because I think we are a little bit over time already. Maybe.
What about the second one from the top? The relation between a benchmark data set and a leaderboard.
Yeah, so I think this is I guess maybe I'll let the other two answer first because I've been answering first a lot. So
I've been kind of relying on that, but to prep. But no, so I think that's a good question. So I think a data set can be multifaceted, and I think when we think data set, the only thing we talk about is like the accuracy on the data set. But you can think of it like in multiple ways, like what attributes, what sort of latent variables are embodied in the data set? Does it only capture like one characteristic of like the population? So is it like only in English for one, or does it only deal with or does it have certain annotation artifacts, right? So there are a bunch of different characteristics to a data set that we don't talk about. And I think because data sets and leaderboards are so intertwined, all the discussion just becomes framed in terms of accuracy, even though there are a bunch of other latent variables that inform the accuracy and other aspects of performance.
If someone could read me the text of the question, that would be great.
What do you think is the difference between a benchmark data set and a leaderboard?
Okay, so that was very straightforward. I mean, practically, so I'm just thinking, sorry, that basis, I'm thinking a lot about Switchboard because I mentioned my background's in speech. And Switchboard is the speech corpus that was collected in before me that has a bunch of telephony conversations between people. And it's sort of like the default benchmark that you use for a lot of ASR work. And since that was recorded, the way that people speak in America, even upper middle class white people speak in America, has changed quite dramatically. So that benchmark is sort of a snapshot in time, whereas I can imagine that a leaderboard where the benchmark was refreshed or changed over time could have a little bit more staying power. Yeah, I don't know. I also feel like, I love y'all, but the majority of NLP researchers today have not had enough training on analyzing data sets and really like, understanding the quality, looking at the data sets, to quote Emily Bender, look at your data. It's not optional. And I think that level of linguistic and awareness and analysis and ability to really look at and understand the data set. I mean, also sometimes in bad ways, like the things that you can gamify to get better results in a particular data set, which it happens. Yeah, I don't know where I'm going with that thought.
Jesse?
Yeah, I think I would just take a moment now if we're sort of closing. I think there's a lot of great information in the Rocket chat that I see. Sorry, Rachel, you can't see it. But what I will say is I'm excited to see a lot of the people here chatting with us about ideas that we've all been having, and also, some authors of papers. There's a couple of great papers that were just posted in the Rocket chat. I'm going to take just a moment and like shamelessly plug everyone else's stuff that they're doing because it's super cool. And I don't see a lot of other opportunity to talk about, this is a cool little micro community of people interested in reproducibility. And one thing that was just posted in the Rocket chat was 2 papers on the reproducibility of standard splits, random splits, and statistical testing. I love these papers. I've definitely read both of them immediately as they came out, and then people also sent them to me because they're super cool. One is We Need to Talk About Standard Splits, great paper title. Another is the Best Better? Bayesian Statistical Model Comparison for Natural Language Processing. Another thing that I'll plug is a pre-registration experiment happening at NeurIPS this year. That's another workshop. And so that workshop is motivated by first registering what experiment you will run, as that's what you submit to the workshop. And then whatever the results of that pre-registered experiment are, you will publish those at that workshop when it happens. And that's one way of sort of guaranteeing people publish negative results. And its publication is not based on the positive or negative aspect of the result, but the quality, the merit of the idea itself. So there's a lot of great work happening, and I'm happy to see this little community of people that have cool ideas that I respect as well. So.
This is awesome. I didn't know about that workshop, but I actually mentioned this idea in the morning because I know that this is done in psychology, and it's cool that somebody is doing this in machine learning, and we should totally do the same. And I guess to conclude with the dataset versus leaderboard issue, one of the things that I came across as I was working on my post about the possibility of publishing a dataset paper was the fact that to publish a dataset paper, you have to show that it's quote unquote learnable, which means you have to provide those standard splits, and because this is a proof of the utility of your data, right? And you have to provide the standard splits, and you have to show that some system can learn it, but not too well. Otherwise, what's the utility of that? So yeah, but my concern with all that has been that once you do that, once you present your data as a benchmark, people will only see it as a benchmark. We have a hammer and it looks like a nail, right? But maybe it's not even the best use for the data to begin with. Yeah, well, that's more of a comment. That's not a question. Anything else? Any closing remarks?
So I wanted to say a couple of words too. So this was a great panel. Thank you, by the way. So my personal takeaways from this discussion, there's at least 2. One, I think we do need different. So I don't think I agree that papers like Roberta need be in findings. I think we need a separate track in our main conferences for these, because these are really good contributions. They're just of different kind. And we have something like that. We have NLP applications, but they're not used this way. At the same time, I think the Sustain NLP workshop that Sam was talking about, I think we also need a separate track at the main conferences doing exactly that. And I think that would make it on even footing with everything else, which it is and should be. And finally, the thing about the leaderboards, I completely agree that reporting one number does not make sense right now, as it did maybe 15 to 20 years ago. But I think the idea of having being best at that particular level of compute makes perfect sense. And so I think that would be good for leaderboards to have, and then you could sort by this category, right? So those are my takeaways from this, and thank you for this discussion.
Yeah, I totally agree. And I also, in my pitching other people's things that were happening earlier, skipped over Sam's the workshop that is happening that Sam is involved in, Sustain NLP, that's also a great workshop. I totally agree. I think, again, I'm optimistic about the future. Seeing things like that, after calling for reporting performance efficiency trade-offs, we then see people coming up with new ways of sorting leaderboards. I think that's great. And I will also just say, in general, we're all still working on this stuff. So if you guys have ideas, I'm around and I am continuing to iterate on these things. So please reach out. I'm happy to discuss and collaborate on things.
And thanks to Anna for organizing this great workshop. Or both Annas, I guess.
Yeah, definitely. Thank you.
All right, let's clap. Please unmute yourselves so we can clap. Totally refuse to unmute and just show the clapping icon. Not the